Assalamu alaikum, myself Salsabil Kassar and welcome to my video presentation on the topic of method validation of zinc determination in acid chloride plating baths. In this presentation, I'll cover the validation of an analytical method used to measure zinc concentration in acid chloride plating baths. Accurate zinc control is critical in plating operations because zinc concentration directly affects coating thickness, appearance and brightness, corrosion resistance. Therefore, this method must be accurate, precise, linear, and sensitive before being used for routine quality control. Objective and scope. The objective of the study was to validate the method TM Zinc 01, which determines zinc using ICP-OES. The method is intended for routine QC monitoring of plating baths with a target zinc concentration of about 30 gram per liters. The validation was performed according to ISO/IEC 17025 requirements. Validation parameters include linearity, precision, accuracy, limitation of detection, limit of quantification, instrumentation and reagents. ICP-OES Perkin-Elmer AVIO 200 Viewing Model Radial Primary Wavelength Zinc 206.200 nanometers Secondary Check Wavelength Zinc 213.857 nanometers Chemicals Trace Metal Grade Nitric Acid 1000 ppm Zinc Standard NIST traceable type 1 deionized water. The diluent used throughout the study was 2% nitric acid. Sample preparation. The plating bath contains zinc at approximately 30 gram per liter, which is too high for direct ICP analysis. Therefore, a two-step dilution was used to bring the concentration into working range. Dilution steps. First, 1 ml sample to into 100 ml flask 100 times solutions, and the second one is 10 ml of the step 1 100 ml flask 10 times dilutions. Final dilution factor 1:1000. Final matrix 2% of the nitric acid. This ensures matrix compatibility and instrument safety. Parameter number one, that is linearity. Linearity checks whether the instrument responds to proportional to concentration. Calibration range 0 to 50 ppm zinc. 5 calibration standards plus a blank. Results correlationship coefficient is equals to 0.99996. Slope is equals to 10480 counts per ppm and intercept is equals to 210 counts. Interpretation. The calibration curve is highly linear across the working range. Result pass meets ISO/IEC 17025 requirements of R2 greater than 0.999. Parameter number 2, precision, that is repeatability. Precision measures how consistent the results are when the sample is analyzed multiple times. Procedure. One plating bath sample was prepared and analyzed six independent times. This tested sample preparation and instrument repeatability. Results. Mean zinc concentration is equal to 30.07 grams per liter. Standard deviation 0.113 grams per liter. Percentage RST is equal to 0.37%. Interpretation. The percentage RST is well below the acceptance limit of 2%. Result pass. The method shows excellent precision. Parameter number 3, accuracy spike recovery. Accuracy shows how close the measured value is to the true value. Method use standard addition, that is spike recovery. Data unspiked sample is equal to 30.07 ppm. Spike carried is equal to 10.00 ppm and measured total is equal to 39.85 ppm. Recovery calculations. Recovery is equal to 97.8%. Interpretation. The recovery falls within the acceptable range of 95 to 105%. This confirms that the plating bath matrix does not interfere with zinc measurement. Results pass. Parameter number 4, that is LOD and LOQ. LOD and LOQ define the lowest detectable and quantifiable concentrations of zinc. Method. Analysis of 10 reagent blanks. Standard deviation of blank signal was calculated. Results. LOD is equal to 0.011 ppm. LOQ is equal to 0.033 ppm. Interpretation. The LOQ is far below the lowest calibration standard 5 ppm, indicating excellent sensitivity. Result pass. Summary of validation results. Parameter result. Linearity pass. Precision pass. Accuracy pass. LOD slash LOQ pass. Final conclusion. The analytical method TM slash zinc slash 01 for zinc determination in acid chloride plating baths has been successfully validated. The method is linear over the working range, shows excellent precision, provides accurate results without matrix interference, is highly sensitive. Approvals for routine use. Based on the validation results, this method is fit for purpose, compliant with ISO/IEC 17025, approved for routine quality control analysis. Closing. At the end, in conclusion, this validation ensures reliable zinc control in plating baths, leading to improved coating quality, reduced process variation, strong compliance with industrial and audit requirements.